Now in part 3 we have seen in part 1 and part 2. In part 1 we done the seasonal decomposition of the time series here. Then we did the find the autocorrelation and check some visualization indications in partial autocorrelation, correlation function and autocorrelation function and lag plot. The main visualizations were these two, ACF and PACF, and we concluded from that we will use an AR model for prediction of degree 1. So for this we will import some libraries from stats models dot TSA dot ARIMA import ARMA model. Now let's see here, this was a deprecated version. When we imported ARMA, this is now deprecated, so that's why I think it is giving import error, not sure. But now we use this stats model.tsa. From stats model we import time, we got the package time series analysis tsa dot arima dot model import arima model. In ARMA we used like somewhat like this. Let's remove this. We imported this. Now we will give it in result variable arima comma, we will give it time series comma. For this we will use one order, 1 degree AR model, and differencing we will use one differencing to make the model stationary, because it will because data is in time series, it is not stationary, so it will not work for non-stationary data. We have to make the data stationary, so this is somewhat the calling step. We will give here difference d1 as the one step differencing. Then we will use 0 degree for MA. For moving average we will use D0. Now we will run this. Here order equal to tuple. Let's run this. We can ignore this warning. This is a warning, we can ignore it. Result. Now we will check whether it is statistically significant or not. For that we will use result.summary. Prior to that we have to fit this ARMA model. Model equal to result dot fit. Now we will see the summary of the model. Summary we have like this. We will go to the p value. For zero dot element and sigma 2 coefficient, these are the two coefficients. We will see the p values. It is 0 0, so it is less than 0.05. These two values are less than 0.05, so it is statistically very much significant, and strictly also significant because it is less than 0.01. So it is statistically significant. We can use this model for prediction. We will give the full time series, not the adjusted closed column only. So we will do it here. Result not fit. Model dot summary. Again, you will check the p-values. It is statistically significant. You can ignore this warning. Now, for a model dot plot will predict it. Will plot the prediction. Plot predict start equal to 1998, comma and equal to 2025. Spelling is not correct. Dot predict. Now we can see here the auto regression AR model of degree 1 prediction. We can see here. That this is the forecasted line and actual data is this. Before the prediction, it is very much matching with the forecasted data. Predicted data is very much matching with the actual data before prediction. But after prediction, it is predicting a constant price. It is predicting for I think 1 or 2 or 3 years in epoch time format. Or in simple words, in till 10,000 index, we had data till 6257 index till here, but it is predicted till 10,000th index. So I mainly wanted to show the plot of auto regression that I have shown here. Prediction is also shown here. And the plot was not very much nicely visualized because the function that I have to use here was of the plot underscore predict, but now that function is now deprecated and it will not work in this Kaggle notebook. The Python has changed that function and now we have to do it all manually to plot that nice plot that we used to plot previously with the function uh, plot underscore predict underscore plot, sorry. That function is no more present, so I tried to show the prediction as much nice as possible. So sorry, so here it is showing here. In auto regression, it generally happens, it always happens, but till the actual data it matches. If the autocorrelation is near 1, then till the actual data it matches the line, like here it is matching forecasted and actual data. But in the prediction case, it always somewhat goes to like sloped line upward or sloped line downwards or the constant line in auto regression. In prediction auto regression, predicted area. So that's the case that was something statistical mathematical model pattern that must be underlying there. That's why it is showing like this. Thank you. Our 3 parts have been done for this auto regression. Now this was the final part. Thank you.